All right, welcome back. Today we've got the 8.3 notes, coterminal angles and evaluating the functions for angles. Now, it doesn't say that on the top of the page. I'd made a last minute decision to use an older set of notes because I like these better. Hopefully the quality is okay. I did have to photocopy them. First thing we want to change is they're not Unit 10 notes anymore. This is now the Unit 8 notes. So if you want to change that to make you feel better, you can. This used to be Chapter 10. Okay, so starting off with coterminal angles. So we want to add or subtract a full rotation to get a coterminal angle. So before we just start looking at definitions and stuff, let's look at an axis real quick. Okay, and what's a coterminal angle? So let's say I'm going to take my pen and I'm going to rotate, let's say 30 degrees. Say right about there. Okay, well, what would be the same as rotating 30 degrees? Well, how about rotating negative 330 degrees? I'm going to spin around and I'm going to end up in that same spot with the 30-degree reference angle. In fact, let's draw that. So let's pretend like I'm accurate here, and let's say that's our 30-degree reference angle. Okay, right here. Well, again, the same thing as rotating 30 degrees would be rotating, negative 330 degrees. Okay, or maybe from 0, I rotate 390 degrees. Okay, so as long as I end up in the same spot with that same terminating ray, that's what we call a coterminal angle. Okay, so how do we get a coterminal angle from any one spot, like from here? Well, I can rotate 360 degrees. I can rotate a positive 360 degrees. That's called a positive coterminal angle. Or I can rotate negative 360 degrees and end up in the same spot, and that would be a negative coterminal angle. Okay, so when they're asking for a coterminal angle, they want an angle that has the same terminating ray. And again, we can get that by either adding or subtracting 360 degrees. In other words, add or subtract one full rotation, like it says here. And you'll end up in the same place you started. So again, that's what we call a coterminal angle. So task 1, find one positive and one negative coterminal angle for the given angle theta. So if our angle is 100 degrees, so if I look at my little chart here, 90 degrees would be straight up, and then 100 degrees just a little bit past that. So this would be, a 100-degree angle. Okay, well then how do I get a coterminal angle to that ray? Well, I can either add 360 degrees or subtract 360 degrees, and I'll end up in that same spot. Okay, so then to show our work, we just want to take our angle, which is 100, and add 360 to it. Okay, so if I add 360 degrees, we get 460 degrees. So that'd be a coterminal angle to 100 degrees. In other words, they would have the same terminating ray and same reference angle and be in the same quadrant. Okay, or I can take my angle 100 degrees and subtract 360 degrees. Subtract one full rotation. So rotate clockwise instead of counterclockwise, and we'd end up with an angle of negative 260 degrees. But that's going to, be a coterminal angle to our original angle there, because it's going to have the same terminating ray, same quadrant, same reference angle, etc. Okay, so that's all we do is we're adding or subtracting the full rotation to get a coterminal angle. All right, next, what if we had negative 400 degrees? Okay, well then I want to take negative 400 degrees, and to get a positive coterminal angle, what do I do to it? Now, here's one thing you want to keep in mind. Do I have to add or subtract just one rotation? Do I have to add 360 degrees? Well, no, it can be any multiple of 360 degrees. Okay, now, some people might interpret this differently. They might say a positive coterminal angle. They might think of it as a coterminal angle that is positive instead of negative. Well, if I do one full rotation, 360 degrees, that's still going to be a negative angle, right? It'd be negative 40. So another option, just to play it safe, just in case somebody wants a number that's actually positive, is we can add two rotations. That'd be fine. So we can do plus 720 degrees. And then what does that give me? 320 degrees. Okay, so not only did we rotate in a positive direction, but we ended up with a positive number. So no arguments there that that's a positive coterminal angle. Okay, because that would have the same terminating ray as my original angle. And then if I want a negative coterminal angle, well then I can take my original angle, negative 400 degrees, and then subtract one rotation, subtract 360 degrees. And then that gives me negative 760 degrees. Okay, so again, to get a positive or negative coterminal angle, you just want to add or subtract one full rotation, which is 360 degrees. All right, so pretty simple. Moving on to the next task. Okay, so the next task, we want to do a bunch of stuff here. We want to sketch the given angle in standard position. So that's just where's the terminating ray. Identify the quadrant for the terminating ray, identify the reference angle, find the sine, cosine, and tangent of that angle. So like I said in class, there's not going to be any one big problem. It's just a problem with a bunch of little pieces. So this one obviously has a bunch of little pieces. So like I said, this sounds like a lot of things, but it's really just one problem that has many moving parts. You'll need a few old friends to help you. First one is SOHCAHTOA. Okay, they wrote it out for us. Great. We need to know, what is sine, what is cosine, what is tangent. So we got SOHCAHTOA there. We also need our special right triangles. Now I left these blank on purpose because we need to practice filling these out. It doesn't matter how you label them, but it looks like this is the 30-degree angle down here, so we'll call that 30 degrees. And if that's 30 degrees, well then how do I label my sides? It's 1, 2, and root 3. Okay? Remember, the biggest side is the hypotenuse. 2 is bigger than the square root of 3. All right, and then next, this one is the same as that, just kind of repositioned. If this is my 60-degree angle down here, well then now it would be 1, 2, and root 3 right there. And then if this is my 45, 45, 90 right triangle over here, then my sides would be 1, 1, and root 2. Okay. All right. And then we're going to add one new friend as well. We want to know where are our trig ratios positive and negative. So where is sine positive? Where is cosine positive? Where is tangent positive? Okay. Now if we look at our little axis here, let's look at, ignore this, the second terminating ray. If we look at our first one we drew, this 30-degree angle, okay, well, what's going to be positive over here? In other words, sine would be opposite over hypotenuse. Well, the opposite side, that's going up, so it's positive, if I'm thinking about like an x and y axis here. This is going up, and then in the unit circle, because that's what we want to imagine on the unit circle. So this is part of the unit circle. Our radius is always positive 1. So this would be some positive number over 1, so sine would be positive. What about cosine? Well, my adjacent side is going to the right. That's going to be in a positive direction. And then this is always positive. So anyways, everything's going to be positive in quadrant 1. Okay, what about in quadrant 2? If I have a triangle here, so let's say my terminating ray ends right there, and then I can make my right triangle right there. Well, let's see. My hypotenuse is always positive. My adjacent side, well, this time it's going to the left, so my x values would be negative, and then my y values are going up, they'd be positive. Okay, so then let's see, sine would be positive, but anything using my adjacent side, like cosine or tangent, would be negative. So all of my things are positive here, just sine is positive here. Okay, what about in quadrant 3? So if I have some terminating ray and then some, right triangle that I make. Okay, well now I'm going to the left, which is still negative. We'll just use that one just go right here. And then I'm going down, this one's negative. And then my hypotenuse is always positive. Okay, so then, sorry if this is getting a little cluttered. Let's see, sine opposite over hypotenuse, that's negative. Cosine, adjacent over hypotenuse, that is going to be negative because it's a negative over a positive. And then tangent would be opposite over adjacent, and negative over a negative would be positive. So in this quadrant, only tangent is positive. Okay, and you'll see a lot of this in other problems, so it'll make more sense later. Sorry if it's getting cluttered right here. I'll try a different color to make it a little more clear for the last quadrant. If I have a terminating ray here, and then some little right triangle, well then now I'm going to the right, so then my x values are going to be positive. I'm going down here on the opposite side, my y values are going to be negative, and my hypotenuse is always positive. So then let's see, the only one that's positive here is when I do this side and this side. The adjacent over the hypotenuse is cosine. So then only cosine is positive in quadrant 4. Okay, and then this is kind of the little cheat sheet that we're going to use, the ASTC. So the way that we memorize that is, well, first of all, it's quadrants 1, 2, 3, 4, so in that order. And then we say all students take calculus, okay? Or maybe more accurate, all students text in class, okay? But anyways, that's how we remember which trig functions are positive here. They are all positive in quadrant 1. Only sine is positive in quadrant 2. Only tangent is positive in quadrant 3. And only cosine is positive in quadrant 4. Okay, and it just all relates to which direction are we moving. To the right, my x values, which is usually my adjacent side, it's going to be positive. To the left, my x values, my adjacent side, is going to be negative. Up is positive for my y's, which is my opposite side. Down is negative for my y's. Okay, so if you forget this, you should be able to figure it out, but this is the cheat sheet here. All students take calculus. So when we get a little axis like this, that's what we want to put. It's just A, S, T, C. So all students take calculus, or all students text in class, if that's easier to remember. Okay, and then that tells us which trig functions are positive and negative in which quadrants. All right, so now we have all the tools that we need to start solving these problems here. All right. Like it says, don't forget to include the appropriate signs. That's where this comes in. Okay. All right, so we are given a 330-degree angle. The first thing we want to do is sketch that angle. So we're probably going to use all the space. So let's go over to the side here. And I want to sketch this angle. We don't need to draw a big axis, just a little one there. And if I rotate 330 degrees, well, how far would that rotation be? So let's see, I'd rotate, this would be 90, 180, 270, and then 330 would be right about there. So I'm going to draw my terminating ray. Okay, well, we're obviously in quadrant 4, so we can answer that part. So we're going to put Q4. And then what is my reference angle? What is this angle right here from my terminating ray to the x-axis? Well, if I rotated 330 degrees, how much further would it be to get to 360? Well, 30 degrees. So then we have a 30-degree reference angle. Okay, and then next I want to find the sine of my angle. So the sine of 330 degrees, cosine of 330 degrees, and probably do it over here so we don't go too low, the tangent of 330 degrees. All right, now let's figure one thing out before we worry about our ratio or fraction. Is, well, since we're in quadrant 4, which function is going to be positive? Well, in quadrant 4, only cosine is positive, which means my answer for sine is going to be negative, and my answer for tangent is going to be negative. Okay, because if I took this terminating ray and drew a right triangle right there, well, my y values are going down. So anything that has my y values in it is going to come out negative. Okay, which is sine and tangent. They both use the opposite side, which is my y values here. Okay, all right, so then what is the sine of 330 degrees? Well, again, we're looking at our reference angles 30 degrees. So then what's the sine of 30 degrees? Well, then we look up at our special right triangles. Here's my 30-degree angle, so sine is opposite over hypotenuse, which is 1/2. So then my answer is negative 1/2. Okay, what about the cosine of 330 degrees? Again, we're looking at our reference angle, so what's the cosine of 30 degrees? √3/2. And that one's positive because it's in quadrant 4. And then the last one, what's the tangent of 30 degrees? Well, 1/√3, so it's negative 1/√3. Okay, and if you wanted to, you can simplify that. I'll just do it right here because we don't have a ton of space. It would be negative √3/3 if we rationalize the denominator. Okay, and then that's our answer. So again, no big, hard question to solve, but a bunch of little pieces. Okay, and it's easy to forget things like the negative, so it's just a lot of little things to remember. Okay, there is number 1. Let's try to section this thing off. You don't have to do this, but since the problems are pretty close to each other, I'm going to try to section everything off. Okay, part B, next part here. This time our angle is negative 135 degrees. Okay, well first we want to draw that. Okay, so we're going to start here at 0 degrees. Negative means we're rotating clockwise. So let's see, this would be 90 degrees, and then I need to go 45 degrees past that to get to negative 135 degrees. So my terminating ray would be right about there. And then, well, what would our reference angle be? Well, since we went 45 degrees past 90, it would be another 45 degrees to get to here. Okay, so then we're obviously in quadrant 3. And we have a 45-degree reference angle. All right, next, what is the sine, cosine, and tangent of that angle? So we're going to find the sine of negative 135 degrees, the cosine of negative 135 degrees, and the tangent of negative 135 degrees. All right, now just so we don't forget, let's do the signs here. Okay, so let's see. We're in quadrant 3, so then that means that only tangent is positive in quadrant 3, which means my answer for sine is going to be negative and my answer for cosine is going to be negative. Okay. One thing you could do too, it's sine of an angle. Right? This kind of looks like sine minus 135, even though that doesn't make sense. If you want to put your angle in parentheses, you can. It's not necessary. Okay. All right. So, what is the sine of negative 135 degrees? Well, again, we want to look at our reference angle, 45 degrees. What's the sine of 45 degrees? 1 over root 2. So it's negative 1 over root 2, which if we want to rationalize that would be negative root 2 over 2. Okay, what about the cosine of 45 degrees? Because again, we're always looking at the sine, cosine, and tangent of our reference angle. This basically just tells us which quadrant we're in, which tells us is it positive or negative. Okay, so then the cosine of 45 is 1 over root 2. So we get negative root 2 over 2. Okay, just like the sine answer. And then lastly, the tangent of my angle, well, it's going to be the tangent of 45 degrees, which is 1 over 1, which is 1. So then positive 1 is our answer for the tangent of our angle. Okay, and then that's part B. Okay, so again, no big hard problem to do, just a bunch of little pieces we got to deal with. All right, and let's look at the next one. So this time our angle is 480 degrees. Okay, so first we want to draw this thing. So let's see. All right, so it's positive, so we're rotating counterclockwise. Let's see, one full rotation would be 360 degrees. I want to keep going. Another 90 degrees would be, so let's see, 360. That'd be 450. And we want to go 30 degrees past that to get to 480, which would be maybe right about here. So we're in quadrant 2. And then let's see, we went 30 degrees past this. So then how big would this angle be here? In other words, our reference angle would be 60 degrees. So we have a 60 degree reference angle. Okay, and then we want to know what's the sine of our angle. So what's the sine of 480? What's the cosine of 480? And what is the tangent of 480? All right, and then just so I don't forget, since we're in quadrant 2, well, which trig function is positive in quadrant 2? Well, only sine is. So then tangent and cosine are going to be negative. So tangent's going to be negative, cosine's going to be negative. I'm going to put those there right now. Okay? And the next, to find the sine, cosine, and tangent, we want to focus on our reference angle. So we have a 60 degree reference angle. So what is the sine of 60 degrees? Well, root 3 over 2. Okay, that's done. Next, what is the cosine of our reference angle 60 degrees? Well, 1 over 2. And that one's negative because it's in quadrant 2. And then finally, what's the tangent of 480? Well, what's the tangent of 60 degrees? Root 3 over 1, so just root 3. So we get negative root 3. Okay, and then we're done. So as you can see, we're going to be using our special right triangles a lot. We're going to use SOHCAHTOA a lot, and we're going to use this thing, the all students take calculus thing, a lot to tell us where we're positive and where we're negative for these trig functions. All right, probably don't even need to section this one off, but might as well keep the theme going here. All right, and then the last one, 315 degrees. If we rotate 350 degrees, well, first of all, what's that going to look like? Okay, so let's see. That's going to be rotating, this is 90, 180, 270, and then 315 would be 45 degrees past that, which leaves us with a 45 degree reference angle. So we're in quadrant 4 with a 45 degree reference angle. Okay, great. Next, what is the sine of my angle? So the sine of 315 degrees, the cosine of 315 degrees, and you don't need to put the degree symbol, and then the tangent of 315 degrees. Might as well I put it on the other two. Okay, first of all, before we worry about the ratio, I want to know, okay, well, since I'm in quadrant 4, which one's going to be positive, which two are going to be negative? Okay, well, in quadrant 4, well, let's see, so only cosine is positive, which means sine and tangent are going to be negative. So I know this answer is going to be negative, and I know this answer is going to be negative down here. Okay, because if I drew my right triangle, well, then anything that has the opposite side in it, my y values, are negative, which would make this and that negative. Okay, And then what's the sine, cosine, and tangent of this is the same as the sine, cosine, and tangent of my reference angle. So what's the sine of 45 degrees? Look up at your special right triangles, and it's 1 over root 2, which we can simplify to root 2 over 2 if we multiply top and bottom by root 2. What's the cosine of that angle? What's the cosine of 45 degrees? Well, same as the sine. It's going to be positive 1 over root 2, which is root 2 over 2. And then finally, what's the tangent of 45 degrees? Again, look up at your special right triangle. Opposite over adjacent would be 1 over 1, which is just -1. And then we're done. So again, just a lot of little pieces to these problems. Okay. All right, moving on to the backside, or next page for you guys. All right, now what happens when our angle falls on an axis? So for example, what if I rotate 90 degrees? And then my point would be right here on the unit circle. Well, how do I draw my right triangle to create a triangle to do the trig stuff with? Well, we can't, right? Because if we draw a line straight to the x-axis like we always do, well, it's just going to be a line. Okay, so this is a special case. This is called a quadrantal. Okay, and remember now, in the unit circle, the radius of our triangle is always 1. Okay, so then, what does that mean for this graph here, this unit circle? Well, it means that this point up here, if I'm going from the origin, I went over 0 and then up 1. So this would be at the point 0, 1. What if I had a 0 degree angle, or let's say a 360 degree angle? Well, that would be right here on my unit circle. Okay, well, what are the coordinates of that point? Well, 1, 0. What if we rotated 180 degrees and ended up right here? Okay, well, then what are the coordinates of that point from the origin? Well, left 1 and then up or down 0. So -1, 0. And then what if we rotated -90 degrees, or maybe 270 degrees? That put me right here. And the coordinates of that point are 0, -1. Okay? All right, now if I rotate, let's say 360 degrees, we end up right here. Well, I can't draw a right triangle, so then how do I get sine, cosine, and tangent for this thing? Well, like it says right here, SOHCAHTOA doesn't work. Okay, now this is where we need to use our other definition of sine, cosine, and tangent. Okay, and if you forget them, that's okay. Just draw, we'll do it in red. You don't even have to draw this, but just draw a triangle. It doesn't matter what quadrant it's in. Let's just put it right here. Let's say this is my triangle. Okay, now normally this would be my opposite side because this would be my reference angle. My opposite side would be here. Well, now those are my y values. That's how far up or down I'm going. Normally this would be my adjacent side. Well, now that's how far left or right I'm going. That's my x's. And then what is this in my unit circle? Well, this is my radius, which is always +1. So instead of sine being opposite over hypotenuse, well, now it's this over that, which is y over r. Okay, so if we have a quadrantal, we have to use these definitions of sine, cosine, and tangent. If we have cosine, normally that's adjacent over hypotenuse. Well, now that's going to be x over r. And then tangent is normally opposite over adjacent. Well, now that's going to be y over x. Okay, so it's good to memorize these definitions over here of sine, cosine, and tangent because sometimes you have to use them. Okay, do you ever have to use this definition of sine, cosine, and tangent? No, these will always work. So if you really, if you have to pick one, you want to memorize these because these always work. Now, since we probably already know, SOHCAHTOA, that's fine. You can use SOHCAHTOA most of the time. And then if you ever get a quadrantal, no big deal. Just draw a little triangle and say, okay, the opposite side is now y. The adjacent side is now x. The hypotenuse is now r. And then you can write these new definitions and use these. Okay? But again, we are going to need to use these when we end up with a quadrantal. Okay? In other words, when our terminating ray is on either our x or y axis. All right, so here we want to sketch each angle in standard position, find the sine, cosine, and tangent of our angle. All right, so let's start with the sketch. All right, so if our angle is 270 degrees, let's see, that would be 90, 180, 270. Okay, so that's going to be right on our y-axis. Okay. All right, so this is a quadrantal, so we need to use these definitions of sine, cosine, and tangent. What are the coordinates of that point? Well, 0, comma, -1, right? Because that's where we're at on the unit circle. Okay, so then we want to use that to find sine, cosine, and tangent. So let's see. The sine of our angle, which is 270 degrees. Well, sine is y over r, which our y value is -1 over our radius is always +1, so we get -1 over 1, which is -1. Okay, so sine is just -1, and we're done. Okay, what about cosine? So the cosine of our angle, 270 degrees, well, cosine is x over r, which is, well, what's the x value of our point? 0. So I get 0 over 1, and 0 divided by anything is 0. So then our answer for cosine of our angle is just 0. Let's scoot this up a bit. Last part, what is the tangent of our angle, 270 degrees? Well, tangent, like it says over here, is y over x. So then my y value divided by my x value is -1 over 0. And what's anything divided by 0? Well, that's undefined. Can't divide by 0. Okay, so then our answers for sine, cosine, and tangent are just -1, 0, and undefined. All right, moving on to the next one. What if our angle is -630 degrees? Okay, let's see. Let's draw that first. So -630 degrees, so we're going to start here. We're going to rotate clockwise. So let's see, we need at least a full rotation. That's -360 degrees. This would be -450, -540, -630. So just going by 90s there. Okay, so we'd end up again on our y-axis. So we got another quadrantal. Okay, what are the coordinates of that point? 0, 1. Okay, and then now that we have that, we want to find the sine, cosine, and tangent of that angle. So what's the sine of -630? What's the cosine of -630? And the tangent of -630. Okay, now we don't need to write the definitions every time. They're up at the top right of your page. Sine is y over r, which is going to be 1 over 1, which is 1. Okay, so the sine is just 1. Cosine is x over r. Well, that's going to be 0 over 1, which is 0. And then the tangent of our angle is y over x, so that's going to be 1 over 0. So that one is again undefined. Okay, and then we're done with that one. Tangent is not always going to be undefined, as you'll see in the next problem. Okay, then part C, getting close to the end here. If our angle is 540 degrees, well, let's start by drawing that thing. Okay, this time we're going to rotate counterclockwise since it's a positive angle. So let's see, a full rotation would put us at 360, then 450, 540 would end up right there. Okay, and the coordinates of that point on the unit circle would be -1, 0. And now you can find the sine, cosine, and tangent. So let's see, the sine of our angle, so sine of 540, the cosine 540, and we don't need parentheses here, but they're not bad. Okay, so sine is y over r. My y value is 0 over the radius is always 1. So 0 over 1, we get 0. Okay, next the cosine is x over r. My x value is -1 over the radius is always +1. So -1 over 1, we get -1. And the last part, tangent, is y over x. So my y value is 0 over my x value is -1. 0 divided by -1 is 0. Okay, so not undefined that time. That time my tangent was 0. Okay, so then those are my answers. So again, anytime you land on one of your axes, your x or y axis, that's called a quadrantal, and that's when you need to use the other definition of sine, cosine, and tangent. Okay? So we need to use these and the location of that point on the unit circle, okay, which is either going to be, well, just one of these 4 points. All right, almost done. Last part at the bottom, and just so we don't have to flip to the other page, we got a little axis over here, so another little cheat sheet. So remember, all students text in class, okay, or all students take calculus. So we can use that to help us answer these next questions. So here, we don't have to solve anything. They just want us to identify all the quadrants where the terminating ray would make the equation true. Okay, so we got the tangent of theta equals 8/5. Now, don't worry about the numbers. The numbers are kind of irrelevant. What do we really want to focus on? Well, tangent is positive something. Okay, well, where is tangent positive? Well, definitely in quadrant 3. And then don't forget it's also positive in quadrant 1. They're all positive in quadrant 1. So in order to get this answer, which quadrants would I have to be in? Well, either Q1 or Q3. So we're going to put Q1 and Q3 because, well, that's where that could happen. In quadrants 1 or 3, I can get a positive answer for tangent. Okay? Next, sine of theta equals plus or minus 7/11. Okay, now again, don't worry about the number. Where can sine come out either positive or negative? Well, it's positive in 1 and 2. It's negative in 3 and 4. So since it has a plus or minus here, well, then that's all quadrants. Okay. All right, next one. Where is cosine squared equal positive 2/9? Okay. Now the tricky part here is I'm going to take my answer and square it, and then get positive 2/9. So what squared is positive? Well, either a positive or a negative. So this one, again, a little tricky, but since it's squared, this one is also all quadrants. Because it can start off negative, and then when you square it, it's going to be positive. Okay. Also, cosine squared theta is like, it's basically like this. Taking the answer and squaring it. It's like the cosine of theta and squaring it. The reason they don't put the exponent right here is because it looked like you're squaring just the angle, just that number. Okay, so they put it here. It basically means the same thing as this. Now, why don't they just write this? Well, because they don't want to have to write the extra parentheses. Okay, this just means you're taking your answer for cosine theta and squaring it. All right, and then the last part. Where does the cosine of something come out a negative number? Again, don't worry about the 5/14. Where's cosine negative? Well, it's positive in 1 and 4, which means it's negative in 2 and 3. So then Q2 and Q3. All right, so then that wraps up the notes. Like I've said before, lots of little parts on these notes. If you have questions, please ask them in class.